Thanks. I'm happy to be here this afternoon. And I've got a lot of updates and about 50 slides and 15 minutes. So I'm going to go pretty quick, but happy to meet up with anybody afterwards to talk about any of the stuff we talk about here or other SAM or PV Watts questions. Okay, I'm hitting the arrow. Did I just hit this? What do I hit? Oh, there. Hit the big pad in the middle. Okay. One of the things that we do a lot is support the other research projects at NREL and beyond. And one of the things that came up through other research activities at NREL was interest in introducing spatial albedo. So if you have the data, we now have a way to incorporate spatial albedo data into SAM, kind of in a pattern across what would be a utility scale plant. So that then impacts the ground irradiance and the rear side irradiance. PVSC, our colleague Silvana will be presenting on the use of this capability in conjunction with agrivoltaics, which is one of the areas we see a lot of growth in, and where changes in albedo underneath the system will be really important probably. We've added a number of bifacial model improvements, and these are all in the newest release of SAM, which happened last November. So a couple months after the last one of these meetings in August. So data, you can enter data in on bifacial electrical mismatch, racking structure losses, rear soiling losses, and some information on edge effects. PV Watts V8. So in the yellow, it says there what the key piece here is from a PV modeling perspective. PV Watts now uses behind the scenes the same detailed PV model and detailed inverter model that SAM uses. So cuts down on the number of models that we have running around inside of our source code. And provides a more nuanced answer than some of the older PV Watts versions did. In addition, we've added options for bifacials, snow, wind snow, monthly soiling, and expanded global weather data availability. It hasn't been announced yet, but you now can go to the PV Watts website, and we have gridded data for Ukraine, Moldova, Crimea, and we think that's going to be a valuable asset. And as Managit was saying this morning, he's going to be releasing the next year TMY files for Africa and up into Europe generally, and we'll be adding those into PV Watts when those are available, and then we'll have most of the globe covered. PISAM improvements. Turns out utilities are always finding ways to make their rates more complicated. And so we've added the latest ability for rate calculations in PISAM. This is also a time to put in a plug. Matt Perlman and I will be doing a PISAM tutorial tomorrow afternoon, talking in greater detail about this graphic. What's the difference between PVLib and PISAM, and what are the things they have in common? What are the things that set them apart? So please come tomorrow afternoon, delay your flight home, rebook. It'll be really fun. PV uncertainty model. So first I'll say, Matt, as a poster over there, which I saw a lot of people looking at, I'm happy to answer questions on this. This has been a great collaboration also with Sandia National Labs. And the idea is to really look at combining year interannual variability with uncertainty about various other inputs to the modeling. And so trying to get at this issue of what is the range of likely outcomes, right? So turns out it isn't always an exact number of kilowatt hours that you're going to get out of your plant every year. There is a range of uncertainty around it. And a lot of work has gone into what are the items that we are bearing for the uncertainty, and then what is the shape of the uncertainty, and what are the inputs and default values for all of those. So feel free to check that out and come talk to us later. In our SDK, so a software development kit, so you can SAM is a downloadable tool, but it is also an open source package that you can contribute to. It is also a engine that you can write wrappers around. So obviously PySAM being the obvious one, but we have other wrappers. And we have some features that are only available in that and not in the desktop version of SAM. And this is one of them. So normally we calculate the module temperature using a series of models, but in some cases people want to enter their own module temperature. So particularly if they have a custom thermal model, and we did some analysis and ended up adding this as a feature as well. We have a lot of battery work in SAM, and we continue to build out dispatch options and other things. We have already had DC or AC coupled PV plus batteries, standalone electric batteries, standalone thermal energy storage. Not talking about it here, but we have a massive amount of modeling capability and concentrating solar power, which leads into thermal storage as well. And we have a new pump thermal energy storage model. And we continue to look at hybrids that combine PV, CSP, battery storage, and thermal storage, and all manner of configurations. Financial model updates. This is a small thing, but you can now enter your ITC collection over multiple years. So if you don't have the tax appetite to take it all in year one, you can take it over multiple years. This is also important for a variety of communities. And you can analyze the difference between ITC and PTC for solar or any project. And we expect to be continuing to add capabilities on the financial front around ITC and PTC as Treasury continues to unroll a myriad of confusing rules on how to deal with the Inflation Reduction Act over the next couple of years. So see that as a growth area of modeling. So those are all in there now. So coming soon. Hybrid simulations, and I've got a couple of projects here that are being funded by a Southern company. So we want to congratulate or thank them. So we're looking at, we already have PV, we already have wind, we already have batteries in SAM, but it's really difficult right now to try to model them collectively as a hybrid system. So we want to model each of them separately, and then add in those outputs, send all of that information to a central financial package, and do it all collectively as you would with just a normal PV system in SAM. Looking initially at a bunch of combinations there. Another one is looking at dispatching batteries and hybrids for net zero dispatch. So it's one thing to offset all of your, say, data center power needs over the year. It's another thing to offset all your data center power needs every hour of every year specifically. And so that's what this project seeks to do, to be able to track that and dispatch into that load shape. Sub-hourly clipping correction. I'm yet another modeler talking about clipping correction. So we will be looking at that, adding a methodology, a user interface component to it in SAM, and providing, it looks like at this point, 2 sub-hourly clipping models, and one was previously presented here, the Southern Company methodology. That creates a matrix applied to an hourly time series simulation. There's another NREL methodology that comes at it from a slightly different mathematical perspective that we will also be adding in, and developed by Andy Walker from NREL. We also have a number of new visualizations that we're looking at. This is a good example of one of these. We have a lot of people that are looking at PV plus batteries behind the meter. And so in that case, you're looking at sort of 4 things that are changing every hour: PV output, battery state of charge or battery output, the load, and then the utility rate that you're paying in that particular hour. And right now that's really difficult to visualize. And so we want to try to put all that into one kind of coherent graphic so that people can see if it's doing what it's supposed to do, particularly on the dispatch side. Future directions. We have a lot of other things that we want to look at. Some of these have been submitted. Not all of these are funded at this point. Happy to take checks after the meeting. So tracker model improvements, I think there's a number of posters that I saw looking at trackers. Our tracker modeling is fairly straightforward at this point, and there are a lot of complexities to tracker modeling and tracker algorithms that we have not incorporated yet. So we'd like to move in that direction. Agrivoltaics, you start including not just the economics around the PV plant, but also the economics and changes around the crops that are grown in conjunction with the PV plant. And that's the kind of the underlying question that a lot of people care about. So we want to have both the engineering pieces, so the thermal impacts on the crops, and the financial pieces, the proper accounting for crop revenues, both in there. We just submitted a proposal on battery thermal management modeling. Right now, we're assuming the battery is in a conditioned space, and someone else, that conditioned space is being handled outside the project. So it turns out sometimes you have to pay for air conditioning. So we've got to deal with that in SAM. That's another area we want to grow into. Off max power point tracker module, temperature impacts during curtailment and clipping. Someone else just mentioned that. So that's, I think, an area of shared interest in the community. Building integrated PV. I mentioned PV CSP hybrids already, continuing to move in the direction of hybrids. And then there's a lot of really interesting DOE solar analyses that are happening at NREL, happening elsewhere. And we continue to add capabilities like the spatial albedo thing I mentioned at the beginning to support a variety of those projects. Thank you very much. There's a big team, so thank you.